So git status. So we are on class 4. Git branch. We are on class 4. We need to check out to main. Git checkout main. Whichever is our default branch, we should go there. And what it is saying, so it is 2 commits behind. So we should say like git pull origin main means what? Your main branch is behind origin main. What is origin? Means in the GitHub, we will have all the thing, right? There is your main branch. Locally also you have a main branch. Your local main branch is just a main. What are is in the GitHub that is called as origin main. That's why every time we do origin, so branch, right? So we need to pull from our main branch. Yesterday I merged to the main branch. So those changes I didn't pull locally. Now I pulled it. So I got everything. Now going further. If I go for here, git branch, now we are starting a new class. Git checkout. As it is a new branch, -b is needed. Class 05. Now if I say git branch, you have all the branches. Where it is active? Class 5. The beauty is like in Linux, you can see class 5 in the prompt itself. Whereas in Windows, you don't see. That's the difference. So now coming here. So we are in this branch. So today is like, so 1st of Feb 2024. Arithmetic operations. I will create a new folder. If I need to create a new folder at this directory level, I can say new folder 02 arithmetic operations. So till now we have worked with the .py files. Let me start working with a Jupyter notebook. For that I can say a underscore arithmetic ops dot ipynb. Instead of .py, ipynb if I do. Then automatically it becomes a Jupyter notebook. What is the difference between an ordinary Python file and a Jupyter notebook? Python file, you just write and execute in the terminal or with a process, command line. Whereas Jupyter notebook, it's like an inline execution. So Jupyter notebook is something the same as what you do in a command line. Means in command line, if you type Python followed by any file name, you execute. In the same fashion, if you just do Python in command line, you get to a interactive mode. Generally, Python till now can be executed in 2 ways. One is the script mode, what we know till now, and the other one is interactive mode. What is the difference is like, in interactive mode, we can do the same statements and we can see the results immediately. Whereas there we don't see the same like that. So that is the difference. Now here, if I see, you can notice that if I say like, name is equal to, say like Python. If it is a string, I can see output. Means everything you define, you see the output immediately. Say like if I say number 2 is equal to, say 200, and number 1 plus number 2, you can assign and see, or same number 3 is equal to number 1 plus number 2. So whatever you are seeing in interactive mode, as it is, you are seeing. So means immediately. So in which case we go for interactive mode? When you want to debug or understand how a feature works, like that. But if you want to create a service, then we need to go for script mode. Okay, sir, all is good. Then why this IPython notebook or Jupyter notebook came to picture? Here, if you want to exit from it, so what is the process? We say like exit. So I come out of it. So once I come out of it, I don't have these variables again afterwards. It's everything cleaned. If I go for interactive mode again, if I say, hey, what is number 1? It says, I don't know. Means a session can be there only for some time. Subsequently, it will not be there. So if you want to persist them, means if you want to see it afterwards, so all your analysis, that's where Jupyter Notebook comes. So in which places people will use Jupyter Notebooks mostly? When you are like a data analyst or a data engineer or like a machine learning modeler, you need to know the list of processes. You need to go on the same thing you want to do furthermore analysis and drill down and developing some things. In all those cases, Jupyter Notebook is handy. For understanding, let's do certain things in Jupyter Notebook such that we will get some kind of learning. Initially, coming to the arithmetic operations. And in the Jupyter Notebook, there are two types of cells. One is Python cell and other one is like Markdown. These are by default. Python is like we have Python kernel, we can do. Markdown means for documentation, means like any kind of comments, anything to write. In the same fashion, you can see all kinds of supports it has. So earlier it is called as IPython, means interactive Python. Then later on, they added support for other languages also. That's why they rebranded themselves as a Jupyter Notebook with all this support. But as we are focusing on Python, we need not consider them. We can just work on it. So first, I want to say like arithmetic operations. Arithmetic operations. By default, if you open, it is like a Python cell. If I want to change to Markdown, I can specify like this. Then any cell, if you want to run, so it is like Shift Enter. If I do Shift Enter, it is coming like this. But in Markdown, if you write like a hash, if you see that, it is coming like this. But after hash, if you just give one space, then the magic happens. Did you see? If you give one hash, it will come like that. So now after this, the second cell is created. But within this arithmetic operations, I want to do some things. Say number 1 is equal to 100. If I run, as it is a markdown, you cannot execute. So we need to convert to Python. So corresponding language. So if you convert, it works. In terms of the family of support, integers has like multiple data types. Earlier in Python 2, there used to be something called as long also. Now in Python 3, everything is treated as an integer only. So if there is any decimal, it is called as a floating point value. And apart from this, within the integer family, we have two things called as complex and Boolean. You can understand complex means real plus imaginary value. Okay, it is an integer family means you can agree. But you may have a doubt. Why Boolean is called as an integer family? That you will understand slowly afterwards. So coming to this first, in terms of the integers or anything. So first, there is a concept called as assignment operator. So this is called as a assignment operator that you need to learn. Means equal to. If you want to assign a value like this, you do, right? Similarly, if I say number 2 is equal to 200, I can do all the assignments. So if I want to further remove these things, okay, this is like this one, fine. Now for this, if I want to assign one value to another, I can say like number 3 is equal to number 2. I need not worry about anything else. I can just directly do. So now if I want to see the outputs of all these three, as you know, we can use like directly or we can write a print statements. And I'm making a print statement of number 1 and I'm asking the type. Type is a built-in function. It is taking the numbers and giving the types of each of them. You can see they were integers. Now coming to the case of addition first. And one more interesting part you need to be aware in terms of this is, generally we have different kinds of arithmetic operations. Arithmetic operations means plus, minus, so multiply, division, so floor division, like that we have. Here, Pipette says that we need to place one place around the operator. Did you see during this process, I placed one space around the operator? It is not mandatory. If you don't give the space also, it works. But it's a good practice. This is one more thing that we are learning. And apart from that, now coming to the addition operations. In addition operation, what you generally do? So you add two values and try to get the type. So I'm adding two numbers to the 3 and now getting the values. So if I need to get the values, I can say number 3 directly or print off in the standard way, number 3 is equal to number 3. So that is the difference between a interactive mode and a script mode. In script mode, we should write in everything specifically. In interactive mode, you can just ask. Similarly, here, if you observe carefully, two integers are added. You got the final result as an integer. Similarly, I take like one more value called as a float 1.0. It's a floating point value. If you print also, it will tell the same. Now for this value, float doesn't mean that it should be positive only. It can be negative also. Negative float we can have. And now, what if you add two numbers of different data types? Can we add two different data types? Until unless they are of same family, we cannot add. An integer and a string cannot be added, as I showed you earlier. Integer and float can be added because both are of same family. Now, coming to the biggest question. So this is an assignment for you, that what is the largest number that can be processed by Python? So you can take any Python version. What is the largest that can be processed? You come back with this answer. You try your best. I took like a very big number, but I can take further big number also. It can process. But generally, every language should have a limit, right? So in Python, it don't have a limit, I can say. But you need to understand what is the maximum value that it can store. In the same fashion, for storing maximum value also, it takes more memory. For storing a smallest value also, it takes a lot of memory. So what is the smallest value that can be stored in Python? That also you need to help Beam. So these were two assignments for tomorrow. You can work. But generally, if you want to work with, so these numbers, if it is like a decimal, so there is something called as decimal module. So from decimal, so import decimal we say. Means decimal is a module. With that we can do. Generally, when you take a very large number, did you see what happened? It is converting to this exponential format. But sometimes it will try to round off and others. If you want to retain a very small values, sometimes if you want to work, we need to work on this decimal. The point of decimal is that you give like 0.0000001. Generally, if you give this much 0, 1, it will try to round off to say 0, right? If I do it outside without this, say like see here, if I do like outside this value 0.000 and this one, so did you see what happened? So it is retaining those decimals basically. And if you see one more example, if I say like 340900 like that, something I wrote. If I take the same thing, did you observe? So here in this case, after 0, so after decimal, if there are zeros in the right side, it makes no sense. That's why it will round off and remove that, right? It will remove that, sorry. Whereas this is not removing. So that is the difference. And also similarly, there is one more kind of thing called as fractions. Import fractions. If you want to retain the fractions, let's say 1 by 3. If I say a fraction of 1 by 3. Did you see that fraction means like what? 0.3333, it will go. So sometimes if you tell this number, it is kind of a rounding off because it's like recursively growing. You can go any number of times in decimal for 1/3, but it will still have threes, right? But in fraction, you can retain that if you want to work. So this is all about working with smaller and larger numbers. Now coming to the basic arithmetic operations, we have like addition, subtraction, multiplication, and division. If you see that, you will understand. The beauty of Python is that in especially Python 3, you don't have any confusion. Whatever you do on a pen and paper, same thing you can see. So addition, same as we do. Subtraction, same as we do. Multiplication, same. Even division also it is correct. There is one very strange problem in Python 2 called as typecasting. So as we came to this Python 2 online, if you type, we can find some place where you can run them. You can open like some editor. So where you can run Python 2. So where I can show you quickly that how it actually works. If I say like print of so what we did here, so 123 by 100, same 123 by 100 if I do. If I run this, yeah, if I execute it, you will notice. Here I did 123 by 100. So I got like 1. So generally 123 by 100 means what? You should get 1.23, right? But here you get 1 only. Why? So that is a problem in Python 2. There is some concept called as typecasting. Now you need not even worry about it. Just know it is a history. If both the types are of same type, the output also should be of same type. As both are integers, the output also should be an integer. So actual result is what? We got 1.23. It is converting that to an integer. Int of 1.23 means what? You will get 1 only, right? So that is what's happening. If you want to see further, I will say int of, so 1.23 if I ask, you see the output the same way. So 1, that's the reason it gave like that. Then what is the solution that they might have done in Python 2? The workaround is like convert one of them to a floating point value, then it will work perfectly. So if one of them is a floating, it will go to the highest one. See, now it is 1.23. When you get this value in runtime, so what they used to do? So a float of 100 like this. One of them they used to convert with a float. When you don't have a direct value, if you are getting from a variable, they used to do with a float function. So then also you get the real value. But we are lucky enough in Python 3, we don't have those problems. As we should know a bit history, I told that. Now coming back, in terms of division, one interesting point here, I will tell you in Python 3. It is not a problem, but it is a feature. What is this feature means? If you see, so 10 by 2, it's a perfect division, you get 5. 10 by 5, it's a perfect division, you should get 2. 10 by 3, it's not a perfect division, so you get that. Now, in all these three cases, you can see something interesting. In Python 3, when you do a division, no matter whether they were integers or float or anything, even if it is a perfect division also, you get a floating point value. So every time it will result in a floating point value. That is what we should be aware of. So whether it is perfectly divisible or not. So now, if going a bit into this division, generally how we do the divisions, let me take like a small markdown session. Generally, if I say like 3 by 10, okay. So what we do on a pen and paper, we do like this, right? 3 by 10, 3 threes are 9. We get the answer. We subtract. We get the remainder as 1. And we do a borrow of 0. And we do like a 9 again. and we do again. So we get like the remainder as 1 and we again borrow 0. So again we take a 3. So it is a continuous fashion, right? Like that we go on doing. So adding. So this is what we do. So here in this process, you can understand it is like a, when it is not a perfect division, it is going like this. But when you want to stop with the first remainder itself, so what you generally do, you stop like this, right? 3 by 3 is there. When you divide for the first time, you get like 1 as a remainder, 3 as a quotient. So you want to stop at this stage and you want to get the values. If suppose, in that case, we can go. Sir, I wrote like a markdown. When I'm running it, it is not showing properly. So markdown has one more syntax called as tick. If you know the tick, which is below your escape key, there is something called as tick key. There are 3 ticks. If I do 3 ticks and if I run, did you see now it is coming as it is? If you have like any kind of this kind of expressions, if you want to preserve, you need to use the 3 ticks and 3 ticks. So generally, if you want to do division, it will go like this. It is like a true division, right? But if you go with one level itself, ordinary division, it will give it like a quotient and remainder. This is nothing to do with Python. It is a general concept. Sir, whenever I don't want the real value, what if I want the quotient and remainder of something? In that case, we should go for different kinds of operators. So to start with, again, going back as we are into the Python, you see here. Generally, there are 3 types of divisions. You will understand now. One is the ordinary division, or like, so true division, which is like ordinary division that we know. So true division means what? You get the final result as it is. Whereas if you are using this called as floor division operator, when you do a floor division operator, you get a quotient. When you do a percentile, you get the remainder, which is also called as modulo operator. So whenever we want, we can choose that. So, and if you want them together, in any case, there is one more built-in function called as devmod. Devmod is a built-in function which will take these values and give both of them together in one place. If I say devmod of 10, 3, you got these values. You see, it is not a perfect divisible. That's the reason it happened like this. Sir, what if I'm going for a perfect division operation? Then things will not happen, but still you get the reasons. If I do like a 10 by 2, so 2 5s are 10, it's a perfect division. Then remainder is 0, quotient, you got it. Even in that case, you can see the same thing. You already know true division, but if I do floor division, you get the quotient. And so, and remainder, you got it. Means when you have a perfect division, so floor division and true division will have the same value. But even in this case, it is giving a integer, right? Not a float. Observe the difference. So whenever you are going for some kind of operations where you're doing a modular operations, say if someone says that, hey, if a clock is running for 35 times, so round, so how many hours right now? If it is has completed, then what you will say? A clock runs how many times? One time it runs means 12 hours. Like that 35 hours means you can calculate. Or like offsetting. So in those cases, we can use it. General importance. And last 2 points in terms of this, you need to aware is that when you are working with the signs also, it makes sense. I will not tell that, but please go through that. You will understand a lot. How the signs play a very crucial role in terms of division. So when you have like all positive, fine. But if you have at least one of them division, floating as a negative, the result will be negative. This is a mathematical thing. But if you have both negative, the output will be positive. So same like what you do on a maths. So, but if you go for this floating division with these negative values, that is very interesting. You need to invest some time to understand. So it will go to the previous and next values. So basically this concept many people will not tell, and many people don't even know about this. So when both are positive, you get the perfect answer. When both are negative, then also you got perfect answer. But when one of them is a negative, you need to get a negative result, right? That's the reason it will try to go to the previous value. So when it is trying to get minus 3.33, so it will go to the previous integer. So like that it works. So that is what one interesting concept. In the same fashion, even for the remainder operation, which is modulo operation also, when you go for like this kind of things, you will see the difference. When both are positive, you get perfect. When both are negative also, you get the perfect number with the same sign. So, but like when both are like not, that is different. So that is what you need to be aware. This is some of the interesting interview questions. That's what I covered. Now going quickly into the other operations in the things. If I say uh, within that, yeah. Yeah. Next is like compound operations. Compound operations. What is a compound operation? And if I want to make it as a markdown, I changed it. Did you see I placed two hashes? Means like I want to be like a subpart within it. So within compound operations, what we can do? Generally, we know that if you have two values, you can add. If I say 100 plus 123 or 124, you can add and you get it. Oh, it's a markdown. Yeah. 100 plus 123. You get like 223. If you want to assign like number one is equal to 100 plus 123, you can ask immediately itself without even a print statement 223. This time it executed and assigned the value. So what if for the number, every time we are trying to add a value, if I say like number plus say 10, number 1 plus 10, you got what? From 223, it became 233. But if you ask again number 1, so did you see it was not changed? Means whatever the additions, you are not changing to the original object. What if this changes you want to make to the original object? Then you say number 1 is equal to number 1 plus 10. So if I ask like, hey, what is number 1? Did you see 233 came? Now this is kind of a related operation. This related operation, I can go with a slight difference. So whenever the case where you have the same variable in the left side and right hand side, in that case, we can use the compound operation. Means number 1 plus equal to 10, which is like same as number 1 is equal to number 1 plus 10. After this, if I ask, hey, what is the value of number 1? So for this existing value of 233, it added 10. So you got like 243. So not only this, we can do number minus equal to say like I am doing some 6 instead of 10. It is same like number 1. Number 1 is equal to number 1 minus 6. If I ask, hey, what is number 1? Did you see it is 234? So not only that, we can do number 1. So multiply equal to say 8 or some 10. It is same as like what? Number 1 is equal to number 1 into 10. And after that, if I ask, hey, what is number 1? You got the value. So like that, we can do plus equal to, minus equal to, multiply equal to. Sir, what if I have a complex operation, not just one thing? You see, number 1 is equal to number 1 something. So if I say number 1 is equal to something like this, it is same like number 1 is equal to number 1 into this entire operation. Did you see the entire operation? If you want, you can place a brace around it. You get it to understand. So after that, if I ask, hey, what is number 1? It will give the value. So whatever is at the time. So like that it will go. And similarly, if I want to get like, I have another number and if I want to do something, so another number I have and I want to do, it is same like adding in this way. Number 1 equal to number 1 by other number. Two variables I have. I did the operation and assigning back. So in this way we work. Next, going further, if I have like, say floating point values or percentile equal to or something else, you just learned about the float equal to something. So for that also, if I want to achieve, so modulo equal to, like this I can do. Hey, what is the value of it? I got it. In the same fashion, I can go for like, there is one more operation called as a power. I will tell shortly about these operations further, but see here. So it is like a power operation. So that also we can achieve. So like this, all of that we can achieve. But you need to understand, Python doesn't support something called as unary operations. Unary operations means I plus I means first assignment and then increment, or increment and then assignment. So those kind of things are not working in Python. That you should be aware of. So next, coming to the second part of these things, the operations which are supported within this are power operations. Just now I showed about the power operation, which we didn't do till now. So we know till now what is a multiplication operator. So this is called as a multiplication operator, right? Multiplication operator. Similarly, if I have two asterisks, it is called as power operator. See, basically, initially, if you see the keyboard, almost all keys they used. So at some point, they don't know what key to use for the power operation. So generally in other languages, we use this operator, caret operator for the power operations. But in Python, caret is for bitwise. That is another operator I will tell. So for this, if I execute the power operations, we can do like this. 4 to the power of 2. If you want to do square root, we can do like this, right? So we can do things. It works perfectly. That is power operation. And here, there is one interesting process. There is some concept called as PEMDAS. You should be aware. What is PEMDAS? In Python, there is concept called as operator precedence. For that, we have some concept called as PEMDAS. PEMDAS means parentheses, exponent, multiplication. So all these things in this order. So if you remember in your schooling, you might have learned something called as BODMAS. BODMAS, right? Bracket and others. So as we are in this kind of languages, we have different kinds of braces. That's why we call the concept of PEMDAS, means parentheses and all these things. In terms of the operator precedence, most of the languages follow the same order. So it is like a bit difficult to understand at this stage. But to come back, I will give some kind of values such that you will remember better. So there is one operator precedence text I will give. So where you will understand the full things. Means generally operators doesn't means arithmetic operations, right? We'll have different kinds of operators. So PEMDAS will tell only about these things only. But what if you have multiple braces? Which braces to prefer? Or like what if you have further things like attributes and other things which you will learn afterwards, bitwise comparison operations. So you need to remember this. It's not that difficult. Daily when you're doing, you will remember. If you have any doubt also, I will give one way to understand. So the order will be basically in this order. So first to last, left to right. Left to right, top to bottom. So, and by default at this stage, you can see about this PEMDAS. So if you see in your operations, it will follow this rule. So how I am telling that it will follow these rules means, if I take these examples, for this PEMDAS rule to understand, if I take this example, you will understand. In this, there are three examples. 64 to the power of 1 by 2. 64 to the power of 1 in braces by 2. And 64 to the power of 1 by 2 in a braces. When you don't have braces, you will get like 3 different results if you observe carefully. When you have braces, things are good. So whenever you have a doubt, you can write a brace. That's the easiest way. So don't use other braces because you don't know at this stage. Use only parentheses. But this is how it works. So similarly, I have some kind of assignment for you in terms of the PEMDAS. You can try with different kinds of values to understand how this PEMDAS works and how to work with it. I can give like a small assignment for you. So to understand this PEMDAS. So you understood this basic PEMDAS flow. I gave like different operations. You try with different examples and see how the outputs are coming. I gave some, food for thought for you to understand which one to take, how to work and others. So take this assignment. I have given some code, follow that and see how it is working. You come up with different questions tomorrow. We will work further on these arithmetic operations and next we will proceed on the string operations.